Students, here I have come with a new topic, that is solution. Many times it happened that students were messaging me that please do PYQs of the previous year questions of the solution or keep this series on. Only I was the person who was not getting the time to do all these recordings, because I am running a offline coaching center also. So I am teaching offline also. So there the JE people are there, JE students are there, NEET students are also there. So bit busy with them. So also the other part of the previous year prelim paper of 2025, I solved it half the way, half is pending, and I'll do it when I get the time, or I'll do it as early as possible. But students were after me for this video which I am making today, previous year questions of the solution topic. See, this chapter solution is very beautiful topic. There is a theory also, and there are a lot of numericals to solve. See what happens, those students whose organic is weak, these are the 4 chapters which will support them immensely, which is that is solutions, electrochemistry, chemical kinetics. Okay, these are the 3 chapters which will support them, like when students have the difficulty in understanding organic chemistry. So we'll go ahead with this topic. First question here, what I have written is this, and okay, so KH value for the different gases, okay, not all are gases, different compounds will say, it is given, different molecules it is given, and you are told to write the correct order of the solubility. See, understand. So KH value is what? KH value is a Henry's constant. What they have given is a Henry's constant. Henry's constant. Now you may get a question, okay, if it is Henry's constant, then why it is varying? It should be a constant value, right? Understand, Henry's constant is a characteristics of a gas. Okay, like every gas will have a different Henry's constant. That is what it means. So constant, don't go with that meaning. Constant value should be same, but for a particular gas, a Henry's constant will be like, it will vary from the gas to gas. So I'll write first which gases are there over here. So this is the argon. This is the argon. First gas is argon. And for this, the Henry's constant value is given to be 40.39. Then carbon dioxide, the Henry's constant value is given to be 1.67. Then formaldehyde, HCHO. This is formaldehyde. This value is given to be 1.83 into 10 raised to minus 5. And last comes methane. Methane's value is given to be, Henry's constant value to be 0.413. One thing you have to understand, what is according to the Henry's law, okay, we can make a note of this, that solubility is inversely proportional to, or solubility of gas in liquid. This makes it more clear. Gas in liquid is inversely proportional to Henry's constant. Henry's constant. Okay, this is what you can make a note of it. So over here, according, if we go by that convention, where the Henry's constant is least, this value is the smallest one, 1.83 into 10 raised to minus 5. So formaldehyde will have the maximum solubility. Formaldehyde will have maximum solubility. Then comes methane. Methane will have little less than a formaldehyde. Then comes carbon dioxide, because it is having little higher Henry's constant. Maximum is for the argon, and its solubility will be least. That is argon. So which option matches over here? Yeah, this is the one. Option C is the one which matches over here. Next question. Define azeotropes. State the type of azeotrope formed by solution exhibiting positive deviation from the Raoult's law. Okay, what is azeotrope? I'll write the definition. If you know this definition, you can just go ahead. Don't wait for me to write this definition. It's just a definition. Like I'm writing it, why? Because you should know what definition is asked. Right? So definition of the azeotropes is that azeotropes are binary mixtures having same composition, having same compositions, having same composition in liquid and vapor phase. Okay, this is what the definition is. And boils at constant temperature. So this is the definition. Like, since this is just a Goa board paper and PYQs I'm not going to go into depth of this azeotropic, what exactly the thing is. Like, this is definition which is expected. The question is for the 2 marks. And the second thing is that what is asked is the type of azeotrope formed by the solution showing exhibiting positive deviation. Always understand positive deviation from the Raoult's law, positive deviation from the Raoult's law, positive, I'll use the same color, positive deviation from Raoult's law exhibit minimum boiling azeotropes. Okay. If it is negative deviation, then it will show maximum boiling azeotropes. That's the thing. So next question is 3. With respect to solutions, answer the following. Draw a neat label graph to represent the dependence of the vapor pressure on a mole fraction of the component in a binary solution exhibiting a ideal behavior. Let's go into the concept. Like, before I draw that graph, we'll go into the concept. Let's say this is the container and this much is the liquid. There are 2 components in the liquid. Component A and the component B. I'll write over here, this is the liquid, this is the level of the liquid. There are 2 components. I'll draw the liquid components this way. Okay, and other component I'll show you this way, which is in little less quantity. Means I will mark this as A and this as B. So B component is in the more quantity, so its contribution to the vapor pressure will be more vapors will be there in the liquid phase, gas phase over here, and blue will be, since it is less, means what, its contribution will be less in its vapor phase. So over here one thing is clear, that this is the solution. Understand, just to write, this is the solution, this is the liquid phase, and this is the gas phase, or this is the vapor phase. This is the vapor phase. Okay, these are the gaseous forms of that. Like, so they are going to exert a vapor pressure, and that vapor pressure will be exerting a pressure on this surface of the liquid. So that is what the definition of the vapor pressure is. The pressure exerted by the vapors on the surface of the liquid in a closed system. This is a closed system. So now coming to this Raoult's law, what does the Raoult's law say? P1 or PA, I will say PA is directly proportional to what? It is directly proportional to mole fraction of A. Means more is the mole fraction, basically tells you about the more is the amount, more is the amount of the substance, more is the mole fraction, like, and PB will be directly proportional to mole fraction of the B. And what I write is, to remove this proportionality constant, P naught A XA, and this is becomes partial pressure of B becomes P naught B due to P naught XB. Means you consider like if there was only one component, only A component is there, B is 0, means XA will be is equal to 1. Maximum value of the mole fraction is 1, no? Means if you consider other component to be not there, XA will be is equal to 1. In that case, PA will be is equal to P naught A. Here if XA A is not there and B is there, only one component, that time PB is equal to P naught B. Now this is telling you about a partial vapor pressure. PA and PB means its contribution to the vapor pressure in this mixture. Okay, this is the thing. Like if you go closely, if you look this closely, this is resembling to the equation of a straight line passing through origin. Y is equal to mx, and this is equal to y is equal to mx, right? And the graph which is given in NCERT is this way. I'll draw the graph how it is shown in NCERT. It is the graphs which are passing through origin. Actually two different graphs it is, but it is done on a same graph, okay, on the same thing it is processed, just to relate the two things. That's why it is done that way. Okay, so over here this axis is telling you about the vapor pressure. This axis is about the vapor pressure. This side also it is vapor pressure. Okay, this is very important, vapor pressure. This is mole fraction. This axis, I need this space, so I am writing so far. This is mole fraction. Okay, so let's say this is the mole fraction. Over here I'll write mole fraction of XA, mole fraction of the XB. This side also I'll write mole fraction of XA is equal to, here I'll write this is 1 and this is 0. This is 0. This is mole fraction to be is equal to 1. Okay, so the thing about the idea, first we'll figure out what is how mole fractions are related to one another. Okay, we'll figure out mole fraction. So maximum value of the mole fraction can be 1 and least is 0. So over here let's say I will do some grading. 1 2 3 4 5 6 7. Okay, so let's say over here this is 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, and this is 0, right? So over here the total sum of the mole fractions should be is equal to 1. If this is 1 then this is 0. Mole fraction of the B will be what? Over here 0.1, over here 0.2, 0.3, this is 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and you see that you take this sum, these mole fractions will be always is equal to 1, sum of the mole fraction of the component. So the mole fraction of one of the component is decreasing, XA is decreasing, and the mole fraction of the other component is increasing. So what will happen to the partial pressures of the XA? If I want to write for the A component's vapor pressure is going to fall. A component's vapor pressure is going to fall. Let us that fall, let's say this is the highest vapor pressure. This is the highest vapor pressure of the XA, the highest vapor pressure. It will fall. It will keep on falling. It will keep on falling. Why it will keep on falling? Because its mole fraction is decreasing, and the mole fraction of the B is increasing, so its vapor pressure is going to increase. It will keep on increasing. So I'll call this as this graph as partial pressure of A, and this graph as partial pressure of B. And this graph, this line is about the total vapor pressure, that is P total. P total will be is equal to PA plus Pb. Okay, so there is one line, graph 1, graph 2 and graph 3. This is what is expected. What is not expected, you have to don't worry about these values. Okay, just write this way, and this will come over here, mole fraction. Okay, this is the thing we have to define. P total is a total vapor pressure. What is PA? PA is partial vapor pressure, partial vapor pressure of A. PB is what? Partial vapor pressure of B. What is P total? It is a total vapor pressure at every point, and this is the graph which is expected from you. Okay, there is one more thing to tell, that in the NCERT it is given as P1 and P2. Like I have written PA, PB. You can draw the same marks and you can get the marks. Don't write like same. It is okay to write PA, PB, and sometime P1, P2 also. Okay, you will not go wrong. Next question is, calculate the osmotic pressure of the 5% weight by volume solution of urea. This is the question. So you need to calculate the osmotic pressure, second part. So I am writing osmotic pressure is equal to what? Osmotic pressure is equal to pi is equal to CRT. This is the formula which you have to write, and writing this formula you have the marks. Means over here, what is C? C is telling you about the concentration of the solution. It is concentration of solution. In short, it is molarity. It is molarity. R is a gas constant. Okay, this is gas constant, which has different values. Like if the pressure is given in bar, then we'll take it the value to be 0.083 liter bar per Kelvin per mole. Units are very important. Okay, over here the value is anyway given. Okay, and T is the temperature. T is the temperature. T is the temperature, which is equal to what? 27 degrees Celsius, which is equal to 27 degrees Celsius. So this is 27 degrees Celsius. We want it in Kelvin. So it is 273.15. Okay, 273.15 plus 27, which is equal to 300.15 Kelvin. You can take this to be approximately equal to 300 Kelvin. Okay, because of that 0.15 will not go wrong. Don't worry about that. Now concentration is the thing which is not given over here. Concentration is not given. So C is not given, means molarity is not given. So C is not given, means C corresponds to molarity. So what is the molarity of the solution? How do we define the formula molarity? To find molarity, we require the number of moles of solute, number of moles of solute. You can do this as a rough work. You don't have to show this molarity, how you are finding number of moles of solute upon volume of solution in liter. Okay, so this is the formula for the molarity, or finding the concentration over here, right? So how to find? Is there a direct number of moles of solute is given? No. What is given is 5% weight by weight. I'll write this in red. I'll explain you this. 5%. What is the meaning of this? 5% weight by volume. What is the meaning of this? It is 5 gram of solute. Understand? 5 gram of solute present in 100 ml solution, right? So what is the molarity? Molarity will be is equal to, how do we find number of moles? Number of moles will be given weight, that is 5 gram, divided by molar mass. Okay, these are the basics you should be knowing. The molar mass of the given substance, I guess it is given urea. 60 is the molar mass which is given. 60. Divided by volume of the solution. Volume of the solution, it is 100 ml. In liter, it will be 0.1 liter. So therefore, when you solve this, I'll write this as 5 by 60 and this is 0.1, which is equal to 5 by 6. You are getting this 5 by 6. You can keep this as 0.83 moles per liter. You are getting what? Molarity over here. Molarity means you are finally getting a C value. C value. You are getting a C value. So therefore, pi is equal to what? 0.83 multiplied by 0.083, that is R value, into temperature is 300 Kelvin. Right? When you solve this, the answer comes to 206.67 bar. Bar is the unit. Now, how did I get this unit? You just keep the track of this. 0.083 was the concentration. I'll just write over here. Moles per liter. The unit of 0.083 was, that is a gas constant, liter, bar, per Kelvin, per mole, and this is Kelvin. The units which are going to get cancelled is Kelvin, per Kelvin, mole, per liter, and what remains is bar, and that is what you have written. And writing the unit is very important because there is a marks for writing units also. Half marks is there for writing unit, half marks for the correct answer, half marks for writing this formula and defining the terms, and half marks for the correct substitution. See, whatever I have written in black, that is what is expected. Sorry, not black. This is not expected. This part is not expected from you to write for the exam, molarity and all. You calculate it in a rough work. It's for your understanding I have done. What you are expected is this. Final. Okay, these values to get the 2 marks. Fine. Next question. Question is, draw a neat label diagram or neat label graph to represent elevation in boiling point of a solution on addition of non-volatile solute to volatile solvent. Okay, first we'll understand that if there is a solvent, let's consider the water only because everyone is familiar with water as a solvent, right? We'll consider the solvent as the water. So there is a water over here. What is the color of water? Water is transparent, but while representing diagrammatically, we show the color of the water to be is equal to blue. Okay, we write the color, we show the color of the water to be blue. The standard convention, showing color of the water to be equal to blue. Like this is water. This is water. Everyone knows that boiling point of water is 100 degree Celsius or 373.15 Kelvin. This is the boiling point of water. Now, what is a boiling point? What is a boiling point? We have to understand that boiling point is like, don't give the definitions like kids 8th standard, 9th standard. Boiling point is the temperature at which any liquid starts boiling. Yes, fine, that is okay. For lower standard, that is okay. But as you are in the 12th standard, the boiling point definition is what? Temperature at which, it is a temperature at which vapor pressure becomes equal to atmospheric pressure. Atmospheric pressure. This is what you should know about the boiling point. So this is water. Only solvent is there over here. This is just a solvent. and it will have a temperature of boiling point to be is equal to 100 degrees Celsius. Okay, what we'll do is I'll draw the graph. We'll start with the graph. What graph you are expected draw. Let's say this is the axis I'm drawing over here. This is the another axis. This is the vapor pressure. Vapor pressure on this axis, and this side it is temperature. Okay, I'll just show that. I'll write over here this one, this level I am writing the dotted. This vapor pressure, this value is 1 atmosphere. 1 atmosphere is the atmospheric pressure. This value is 1 atmosphere, which is atmospheric pressure. Now this is just a solvent. Consider just a solvent. By definition, what is a boiling point? It is a temperature at which vapor pressure becomes equal to the atmospheric pressure, right? It is a vapor pressure at which temperature become vapor pressure becomes equal to the atmospheric pressure. So water is there and we start boiling it. We are boiling it. Let's say this is the temperature. This is how the temperature is increasing in this direction. This is how the temperature is increasing in this direction. At this temperature, let's say here is the vapor pressure. At some higher temperature, this is what the vapor pressure. At some higher temperature, still higher temperature, this is what the vapor pressure. At some still higher temperature, this is what the vapor pressure is. So then there comes this temperature at which this is the vapor pressure. Now this is the vapor pressure at this temperature means what? Right? This temperature has become equal to what? This vapor pressure has become equal to the atmospheric pressure. I'll try drawing a line through this. It is this way. So this temperature is what? This temperature is the, like for water it is 100 degrees Celsius. This temperature is what? Is the boiling point of this. I'll write that to be T naught B. Okay, this is T naught B. And what you do is to this same solvent you are adding some solute, non-volatile solute. To this solvent you are adding some amount of the solute. So when you add solute, what will happen? Surely the color of this is going to change, right? The color of this is going to change and it won't be a solvent now. You will call this part to be what? A solution. And this temperature will be, the boiling point will be what? Over here. Boiling point over here will be what? Boiling point over here will be more than 100 degrees Celsius. In case of water, generally when we say it will be more than that of the solvent. Okay. So over here what will happen is that to attain a same vapor pressure, and this is for the solution. This was for the solvent. And this another line you can draw for the solution. To attain this pressure, you will require what? You will require this much temperature. This is what? Tp. And this gap is delta Tb. Okay. So this is the gap which tells you about the elevation in boiling point. More is the amount of the solute, more will be the gap. This 100 degree is only for the water. For different solvent, it will vary. Right? This is the graph which is expected from you to draw. You have to define what is T naught B. You have to also write. You have to write this temperature full. Like you should be writing it this way. No short forms for the exam. This is T naught B is what? Boiling point of solvent. See, I'll tell you, when you understand something and write, no, that time remembering becomes easy. You must have heard this several of the time, but today one more time I'm telling you. When you understand something, the remembering becomes easy. Boiling point of solution. This is the graph which is expected from you to draw. Okay. Next, what is asked is calculate the molar mass of the substance when 12.5 gram of a solute is added to 250 gram of water, which elevates the boiling point to be 0.50 Kelvin. You are told to find the molar mass. So this formula, this question is about the elevation in boiling point. Delta TB is directly proportional to molality. Molality tells you about the more amount of the solute. Okay, when we start, okay, I'll just start with this. Directly proportional to molality and to proportionality constant. When I remove this proportionality sign, I'll introduce a boiling point elevation constant, which is equal to Kb. Now, what is the formula you can write for the exam? You don't have to write everything. You have to write this formula. Kb, molality is further written as Wb, Mb, 1 by Wa into 1000. Okay. Now you know, I'll define this delta Tb. What is delta Tb? Delta Tb is elevation in boiling point. Elevation in boiling point. How much is that given? That is given to be is equal to 0.5 Kelvin. 0.50 Kelvin. Difference, whether it is in the degree Celsius or the Kelvin, the difference will be same. Okay. Kb is also given. Kb is boiling point elevation constant. Boiling point elevation constant. That is equal to 0. Over here the units are important. 0.5 Kelvin kilogram per mole. Okay. Then Wb is mass of solute. How much is that given? 12.5. Yeah, 12.5 gram. 12.5 gram. Wa is what? Mass of solvent. Mass of solvent is 250 gram water. This is 250 gram. Right? What is the thing you need to find? Mb. Mb. This is what we need to find. So from this formula, if I rearrange this, okay, if I rearrange again, Mb will be is equal to Kb delta Tb Wb Wa into 1000, right? So just substitute over here. Mb, molar mass of the B represents solute. So Kb is how much? 0.52. Units I'll discuss. This is 12.5 gram. This delta Tb is what? Delta Tb is 0.5. Wa is what? 250 into 1000. So when you solve this, we can go ahead with this. No. See, this is 0.5. 0.5 could be also written this way. 0.52 could be also written as 1 by 2. I'll just tell you the think without calculator, without giving lot of shot to your brain, you can solve this. This will go on the top, 0.52, and this 12.5 will become what? 25. This will go on the top, it will get multiplied over there. This is 250 into 1000. So 25 tens are 10 and 10. So answer becomes 0.52 grams per mole. This unit is very important, otherwise we will lose half marks. How we are getting, like molar mass unit is what? Grams per mole, but how we are getting it from here? So let's talk about the units also. I'll talk about the unit of this, how we are getting this. 0.52 was what? Kb, right? That is Kelvin kilogram per mole. 0.5 was the difference, which was in Kelvin. Now over here 12.5 is gram, and this is mass of the solvent, which is in gram, and along with this multiplier, this is a conversion factor which makes it in what? Kilogram. So this is kilogram. 250 means it is as good as 0.250 kilogram, because the definition of the molality is number of moles of solute upon mass of solvent in kg. So now what are the things that will get cancelled? Kilogram, Kelvin, Kelvin. What remains is grams per mole. Therefore MB is equal to grams per mole. That's it. Next question is, draw a neat label diagram for the reverse osmosis. I have already kept the diagram over here. This is the diagram you need to draw. This is from the NCERT. What you can see is that this is the side, this is the side, this side is the salt water, which is what? Which is solution. Okay, there is a semi-permeable membrane. This is a semi-permeable membrane. Okay, it is mentioned over here. This is semi-permeable membrane, SPM, and you are applying the extra pressure from here so that only solvent molecules goes through this. Means solute, that is a salt just remains over here, and only you get a fresh water from this outlet. That is what the thing is. Calculate the osmotic pressure. Okay, there is a question about the finding the osmotic pressure of a solution. Calculate the osmotic pressure of a solution containing 68.4 gram of sucrose in 1 liter of water. So osmotic pressure formula we have solved just now one question CRT. Okay, pi is equal to CRT. This is the formula. Concentration, how we will find 68 gram of the glucose, and molar mass, like C represents what? C represents molarity. C represents molarity. So what is molarity is equal to? Molarity is equal to number of moles of solute. A number of moles of solute is given weight, that is 68.4. Well, right over here, molarity is equal to, that is C, it is number of moles of solute upon volume of solution liter. So first we'll find number of moles in the numerator, that is 68.4, that is given weight, upon molar mass is what? 342 grams per mole. This tells you about the number of moles, and volume of the solution is 1 liter. Directly it is given 1 liter. This gram and gram will get cancelled, and this will go in the numerator. So finally it is becoming what? 68.4 divided by 342. I'll write this as moles per liter. I'll write concentration is this way only directly. 68.4 divided by 342 moles per liter, 0.083, and temperature is 300 Kelvin. So this final answer comes to 4.98 bar, which is approximately is equal to 5 bar. So you'll write this answer. Okay, don't go for approximation. If it was a MCQ, we would have written it this one. 4.98 approximately. Okay. Name the deviation in an azeotrope shown by a mixture of ethanol and acetone. Okay. So ethanol and the acetone. Ethanol and acetone shows ethanol plus acetone. This shows positive deviation. Positive deviation. If it is a positive deviation, then what type of azeotrope? Minimum boiling azeotrope. Minimum boiling azeotrope. So over here, why mixture of this ethanol and acetone shows the minimum boiling azeotrope? Understand, over here for the positive deviation, what is the thing? AB forces should be, like, this is not something which you have to write. I'll use a different color. I am just explaining the concept, where AB forces are weaker than AA and BB forces. Now what is AA force? You consider the ethanol and the ethanol. You consider the ethanol and the ethanol. This is one intermolecular force, OH. And there is another OH, another ethanol molecule. Okay. What kind of force existing among this is the strongest intermolecular force? That is hydrogen bond force. Okay, here the force which exists is the hydrogen bond force. Now in between there comes a acetone. In between there comes a acetone. Acetone is this, which decreases this intensity of the force between two ethanol molecule, and it forms a new force which is a dipole-dipole force now. Okay, therefore this new force, like this is our A and this is our B component, so AB force is a dipole-dipole force which is weaker than AA. Earlier it was A and A, which is a stronger force, which was hydrogen bond force. Or it will be, this dipole force will be, this new dipole force will be weaker than the BB dipole force, right? In a binary mixture, if the mole fraction of one component is 0.386, then the mole fraction of the other component. The sum of the mole fraction of the any number of the components is always equal to 1. Binary mixture means two component, mole fraction of XA plus XB is equal to 1. Right? What they have said that one of the component is this. Let's consider XA to be 0.386. And you are told to find this. So therefore, XB is equal to what? 1 minus 0.386, which is equal to 0.614. So your answer is C, option C. Isotonic solutions are the solutions having same osmotic pressure. Simple, right? Directly given in NCERT. The increase in the boiling point of a 0.5 molar solution of 0.5 degrees Celsius. 0. is 0. Like elevation in boiling point is 0.5 degrees Celsius. The molar elevation constant is asked. So this is, molality is also given over here. I'll use this formula, that is delta TB is equal to KB into molality. From this the other formula come, right? The bigger formula. So over here delta TB is given to be is equal to what? 0.50. This is the elevation. The increase in the boiling point means what? Elevation, or the difference in the boiling point. Kb you need to find, and the molality is given as 0.05. So therefore Kb will be is equal to what? 0.50 divided by 0.05. This answer comes to be is equal to 10 Kelvin kilogram per mole. This is the answer. Mixing of acetone and chloroform occurs with the reduction in the volume. Name the deviation from the Raoult's law shown by the above mixture and state whether the process is endothermic or exothermic. Acetone and chloroform. Okay. So whenever one acetone is there, if you understand the acetone structure, before I tell you the answer, let's understand the concept. Concept is this. There is one acetone molecule and there is another acetone molecule. There will be a very large number of the acetone molecule. By looking this, what we can say that there is a partial negative charge. Over here there is a partial positive charge. Basically this kind of thing has a dipole-dipole force. What is this force? A dipole-dipole force, which is weaker than a hydrogen bond force. Dipole force. And there is a chloroform. What is chloroform? CHCl3. CHCl3. This is another chloroform molecule. What kind of force is existing between them? Is again, what I can say is that this is partially negative, right? Sorry, partially positive. Electronegativity difference. Concepts are deep, right? So over here also there is a dipole-dipole force. Dipole force. This force is weaker than what? Hydrogen bond force. Now whenever both the component mixes, and here new kind of force is formed. Let's understand what kind of force it is. This is chloroform, this is chloroform, this is chlorine, and there is a carbon double bond, and this is CH3, no, acetone. So there is new force which is formed over here. This force is known as a hydrogen bond force. This is hydrogen bond force. So hydrogen bond force means what? New force is stronger than the earlier one, which is dipole force. Right? This is our A. This is our B. So B and B. This is B. This is A. B forces are weaker than AB force. Means what? Negative deviation. So answer is negative deviation. Over here the answer will be negative deviation, and delta H will be exothermic. Negative deviation, remember, delta is also negative since it is exothermic. Process is exothermic. Process is asked, right? So you have to write exothermic and the negative deviation as the answer. Next question is a vapor pressure of 5% aqueous solution by mass. Okay, calculate the molar mass. Okay, this question is about relative lowering of the vapor pressure. Okay, the vapor pressure of a 5% aqueous solution by mass of a non-volatile organic substance is 373 at 373 Kelvin is 745 mm of mercury. Calculate the molar mass of the solute. Question is bit tricky but not very tough. They have given the vapor pressure of water, means that is a solvent. This question is about relative lowering of the vapor pressure. I'll write the formula relative lowering of the vapor pressure. See, P naught A minus PA is the lowering of the vapor pressure. When I put P naught A, it is relative lowering of the vapor pressure, which is equal to, this is the formula, WB MA MB and WA. So we know the meaning of this. What is P naught A? I'll just write short form, vapor pressure of pure solvent alone, right? PA is what? This is after adding non-volatile solute. This is partial vapor pressure, or this is vapor pressure of the solution. This is vapor pressure of the solution, I'll write. Vapor pressure of solution means when you add solute to this. What is the WB? Weight of solute. What is MA? Molar mass of solvent. And WA, weight of solvent. Weight of solvent. So what is the thing? Calculate the molar mass of the solute. Means you need to find, 1 minute, what I did, WB, MA, WA and MB, right? MB is pending. This is what we need to find, molar mass of solute. Molar mass of solute. So we know that vapor pressure of the So what we know over here is that this is 760 minus 745 divided by 760, like pure 760, and they have given 745. Weight of the solute is 5 grams, means 5% aqueous solution means what? It is a 5 gram in a 100 ml. M2 we need to find, and the molar mass of the water, this is Ma is the solvent, and water it is 18 grams per mole, and weight is 95. When you solve this for M2 will come to 5 into 18 into 760 divided by, like this difference will be 5 now. This difference will be 5. Okay, I'll solve this step by step. Purpose of this class otherwise wouldn't be solved. This difference 760 minus 745 is 15, not 5. 760 So therefore molar mass will come to is equal to, M2 will come to is equal to 48 grams per mole. This is the answer. So next question asked over here is differentiate between positive deviation and negative deviation from the Raoult's law exhibited by the binary solution. So we'll write the differentiating point, like just 2 points are expected. I'll write 4 or 5 points over here, and out of which 2 you can write. This is for 2 marks. Okay. So I'll write over here for positive deviation. Another is Negative deviation. So first point is what I can write about the first point is the interaction between the components are less than in the pure components. Means what we can write is AB forces are weaker than AA or BB forces. Okay, so over here for the negative deviation, AB forces are stronger than AA or BB forces. Okay. Or other points you can write this as an interaction between the components are less than in the pure components. Okay. The other way of writing this could be this way also. Okay. Or you can write the statement like this: the interaction, whichever you feel comfortable. Okay. Interaction between the components are less than in the pure component. In the pure components. Okay. Whether you write this or the other way. So other side, the interaction between the components okay, this is what you can write. For the second point could be like delta H of the mixture or enthalpy of mixing is positive. This is another point. For positive deviation, it's very simple. For positive deviation, delta H is positive, or you can write dissolution is exothermic. This is one and same thing. Dissolution is exothermic. Never be like make this as 2 point and expect full marks for this. Like delta H is positive is 1 point, dissolution is exothermic. You will get only 1 marks for this. Okay, now over here, delta H of the mixture is negative. And or what we can write is dissolution is, sorry, I made a mistake over here. This is endothermic. Positive means endothermic, no, sorry. And this is exothermic. Okay, then volume, the change in the volume of the mixing, this is also positive. So delta V of the mixture is positive. Okay, and delta V of the mixture is negative. Okay, examples, in terms of examples, you also can mention many examples over here. This will be also the differentiating factor. You have to write only 2. You don't have to write so many differences for 2 marks. Expected is just 2. Like ethyl alcohol and a cyclohexane. Ethyl alcohol plus cyclohexane. This shows positive deviation. Okay. Second, acetone plus carbon disulfide. This also shows positive deviation. Third example could be benzene and acetone. Benzene plus acetone. Fourth example, I'll just write the formula: CCl4, carbon tetrachloride, and chloroform, CHCl3. Acetone plus ethyl alcohol. If you can remember these points, it can help you a lot, not only for the differentiating factor. Others question can be framed based on this positive deviation and negative deviation. Just remember this list. This is also very important. What happens? Many students are not able to figure out based on the concept. You don't remember the concept, what happens, and can't judge the deviation. Better is you by heart this and get the marks for this. For the negative deviation, acetone plus chloroform. Okay, then chloroform plus diethyl ether. Diethyl ether. Nitric acid. Acetone plus aniline. Water plus nitric acid. Okay. Diethyl ether. If you study these many examples, and that will be enough for your knowing the compounds which shows positive and the negative deviation. Okay, so just focus on this. Like I'm just highlighting this not only as a differentiating factor. This is a thing. This is a set everyone should be knowing, because many times they form a question directly giving the example, like these are the compounds are there, what kind of deviation will be formed. Try by hearting this. State Raoult's law for the binary solution containing volatile solute and the solvent. See Raoult's law statement I'll write. What it says is that at a given temperature, for a solution of volatile liquid, for a solution of volatile liquids, the partial vapor pressure of each component in a solution is equal to the product of the vapor pressure of the pure component and its mole fraction fraction. Like if there are two components, we write partial pressure of A is equal to P naught A XA. XA is a mole fraction. Another component B is their partial pressure of B. We write P naught B into its mole fraction B. Like this is the thing. Now for the question it is asked is draw the graph for the deviation of the Raoult's law with the solution of the phenol and the aniline. Phenol and aniline, if you observe, phenol intermolecular hydrogen bonding. If you consider the intermolecular hydrogen bonding in the phenol, this is just for your explanation. You don't have to write, show this for the exam. This is for you to remember. I am writing this. Otherwise, what is the point of making this video if I am not explaining you the how to understand the positive deviation or the negative deviation? Okay, because data is everywhere it is written. You can just Google it for the question, you will get the answer, right? This is phenol, and this is aniline, right? See, there is a intermolecular hydrogen bond. If you consider another aniline, then this is hydrogen, this is NH2, and when they combine, when they interact, there will be a strong hydrogen bond force. Even in case of phenol, even if you observe phenol structure is this way. I consider another phenol, and intermolecular hydrogen bond force will be there again. So when these two solutions, which intermolecular hydrogen bond force is there, you mix them, there is an increase in the hydrogen bonding. So new force which is existing in a mixture, that will be stronger than the previous one, means the interactive forces of the new solution which is formed by mixing these components will be stronger than the previous one, like in the pure components. So this will show what negative deviation means. You need to draw the graph for the negative deviation. Now how does the graph look for the negative deviation? Okay, it's very simple. It is this. Two components, right? This is vapor pressure. This axis is of the vapor pressure. This axis. Okay. This is mole fraction. This is mole fraction in this direction. So I will write over here x1 to be is equal to 0, or one of the component phenol, you consider that to be is equal to 0. Don't mention phenol or something. This is 1. x2 is 1 over here, and x2 is 0 over here at this end. Like normally, how is the graph? Normal graph, if we ask for the ideal solution, we'll represent it with some color. Since I have a scope over here to represent that with a color, this is a straight line graph which you will get, right, for the ideal solution. This is another graph for the other component, right? And this is the mixture, but this is for the ideal, right? For positive deviation, what graph are we going to get? For positive deviation, what graph are we going to get? So positive deviation, we simply show it this way. Sorry, it is negative deviation. No? So negative deviation, like this is what is expected, right? This is what is expected. But you are getting a less than what is expected. So this is what the curve less. You have to put the graph below, like this curve you have to write. Okay, this is the thing. So over here, this is, let's say this is P1, this is P2, and this is P total, this graph. So this is what is a graph for the negative deviation is expected from you to draw. Okay. Next question is from the freezing point, because this type of question I haven't done. This is a question which is really unique in this series. So I will be doing this. So question asked is calculate the freezing point of the solution. Okay, first we'll understand the freezing point depression. This question is directly from the freezing point depression. See, we know that delta TF is a depression in the freezing point, which is equal to, is directly proportional to molality, and we write this Kf into molality. Kf is given, right? Kf, the molar depletion constant for the depression constant is given as 1.86 Kelvin kilograms per mole. This is what the unit is, right? Molality. What we need to find is delta. First we'll find this delta TF, then calculate the freezing point of the solution. We'll come to that later. Okay, first we'll find this depression, how much is the difference. So for that I require a molality. What is molality? What is molality? Molality is number of moles of solute upon mass of solvent in kg upon mass of solvent in kg, right? So over here molality is equal to what? What is the number of moles of solute? Our solute is a glucose whose molar mass is 160 and how much weight it is? 1.05. So how do we find moles? We find given weight, that is 1.05 gram, upon its molar mass, that is 160 grams per mole, and upon what is the mass of the solvent? Sorry, glucose molar mass. Molar mass of the glucose, how much it would be? Molar mass of glucose is 180. Sorry, I made a mistake. This is 180, and this 160 grams is the mass of the solvent, means 0.160 kilogram. You want mass of the solvent in kg. When you solve this, you'll write molality is equal to 1.05 upon 180 and upon 0.160, right? So what will be the molality? Molality will be is equal to 0.0364 moles per kg. This is the molality. Therefore, delta TF is equal to, how much is the Kf given? Kf is given as 1.86 Kelvin kilogram per mole, and this is 0.0364. So delta TF value, what I am getting over here is 1.86 into 0.0364, 0.0677. I'll round it off 0.068 Kelvin. This is what is a depression in the freezing point I am getting. Okay. Yeah, no, this is 1.05 gram upon 160, 180, since it is glucose, 1.86. One minute. Yeah, this is what the delta TF is. So what is delta TF? We know that delta TF is T naught F minus TF. Now what is T naught F? It is freezing point of water, which is equal to 273.15. Sorry, not 273. Yeah, 273. 0 degree means 273.15 Kelvin. And this is TF is a freezing point of solution. after adding non-volatile solute. Freezing point of solution. So I know this is 0.068 is equal to 273.15 minus TF. So what is my TF? Is 273.15 minus 0.068. So difference is very small. It is coming to 273.082 Kelvin. This is the answer.